All right, welcome. We're going to go through the review for our 5th 6 weeks test. Okay, guys, this covers a lot of material. And this test is going to cover all the way from the very beginning of the 5th 6 weeks, even into the end of the 4th 6 weeks. So we got a lot to cover. So I'm going to do the odds with you, and you guys will do the evens. So the vertices of quadrilateral A, B, C, D are A, -4, -6, B, -5, -1, C, -2, -2, and D, -3, -5. What is the most precise classification of A, B, C, D? Okay, so they just give us these points, and we have to choose, is it a square, rhombus, trapezoid, or none of the above? So this one, we have to find the distances. Whenever they're asking you for the most specific name, you use that distance formula. So remember, we've got AB. Okay, we got to find the distance of it. And the distance formula is on your formula chart. Okay, now to make your life easier, you can just do A minus B. So we can do -6 minus -5, you square that, plus, so you have to get the x from both of them. Okay, and then now we do the y's. It's -4 minus -1, and square that. And remember, just type this into your calculator exactly as it is. Don't forget these minus the negatives. Okay, if you mess that up, you're going to mess up your whole thing. So this comes out to be the square root of 10, which is square root of 10, 3.16, so it's about 3.2. All right, now we'll do BC. Okay, and again, it's the x's, you subtract them and you square it. So B minus C, so -5 minus -2 squared, plus, and then now we do the y's, -1 minus -2, and again, square that. And type this in the calculator exactly as is, and you'll get the square root of 10 again, which is 3.2. Then we got to do CD. Okay, so our x's, it's going to be -2 minus -3, square that. And then the y's, so -2 minus -5, and square that. And again, you'll get the square root of 10, which is 3.2. And then the last one, you have to go DA. Okay, so DA. So first we have to find the sides, all the sides here. So you have -3 minus -6, you square that. And then you have -5 minus -4. You square that. And again, you will get 3.2. So those are the side lengths. Step 1 is always the sides. Step 2, so all of our sides are the same. So let's look over here. Trapezoid, not all of your sides are going to be the same, so we can get rid of that. And it's probably not going to be none of these, but we'll check between a square and a rhombus. So the second thing you have to do now is find the length of your diagonals. Okay, that's step 2. So we're going to do the distance formula again, but we got to do the diagonals. Now, do y'all see how this is called A, B, C, D? That means it's going to go A, B, C, D. Okay, like this when you're looking at it on the picture. So AC is a diagonal and BD is a diagonal. Y'all, if you get confused, your test has graph paper, so you can graph it. Okay, and you might be able to count some of the distances, but like if they're on a flat or like a horizontal or vertical line. But just plot it so you can see the diagonals. So we got to find the length of AC. Okay, so AC is going to be A minus C, so -6 minus -2 squared. Okay, and then we got to do the y's. So it's -4 minus -2 squared. Okay, and when you do this, you get the square root of 20, which that's how I left mine, but y'all are going to get decimals. So square root of 20 is about 4.5. Let me round to the nearest 10. Okay, and then our next one we have to do is BD. Okay, so B minus D. So -5 minus -3, square it. And then -1 minus -5, square it. And you work that out, you'll get the square root of 20, which is, again is 4.5. So since all four of our sides are the same, we know we have either a square or rhombus because both of them have same length sides. The determining factor, though, is the diagonals. On a rhombus, your diagonals don't have to be congruent, but on a square, they have to be. And so since both of our diagonals are the same and all four of our sides are the same, we have a square. Okay, I'll give you a hint for number 2. On this one, it says, which of the following is the best name or names for the figure? You need to make sure that you choose all of the names that it could go under, okay? So it could be just one, if it only fits one. It could be 2, it could be 3. But you have to make sure that if it fits at least one, you got to make sure that you've properly classified it under all of them. So number 1 is asking for the most specific. Number 2 is asking which one could it fall under. Okay, number 3. How can you verify that QR, segment QR, is parallel to segment ST and that RS is parallel to TQ without using the slope formula? Okay, y'all. Just go through and start looking at these things. Use the distance formula to show that QS, so we're talking about the diagonals here, QS is equal to RT, so congruent diagonals. Therefore, QRST is a parallelogram. So QR is parallel to ST, and RS is parallel to TQ. Okay, just because we got the same diagonals doesn't necessarily mean that they are a parallelogram. Okay, so we can't really, because if we're trying to show that the pairs of sides are parallel, then we have to show it's a parallelogram. So this one, it's a maybe. Okay, now this one, it says use the distance formula to show that QR is congruent, is equal to ST. Okay, guys, if we're just showing that they're the same length, does that tell us if they're parallel or not? No. Parallel, they have to have the same slope, so that doesn't help us. We don't care about side lengths. Okay? Use the midpoint formula to show that the midpoints of QS, so again this diagonal, and RT, the other diagonal, are the same. So if the midpoints are the same, then they're crossing right there, and that would mean that they're being bisected. So that means that QS is cut in half like that, and RT would be cut in half like that. So if their midpoints are the same, then the diagonals are bisected. Okay, and that is a property of a parallelogram. So this is a maybe. And then now J. Use the midpoint formula to show that the midpoints of RQ and ST are the same point. Okay, guys, RQ is this side over here, and ST is this side over here. Do we care if the midpoints of these sides are the same? Does that help us prove if it's a parallelogram or not? No. So get rid of that. Okay. So let's look between F and H. Either we're going to use the distance formula to show that the diagonals are the same length, or that the diagonals have the same midpoint, which means that they bisect each other. Okay, remember, on this one, if you have an isosceles trapezoid, guess what? Your diagonals are going to be congruent to each other. But does that mean that it's a parallelogram? Because if it's an isosceles trapezoid, it can't be a parallelogram. So that's why we can't use F, okay? You have to use H, because if you're going to show that something is a parallelogram, the midpoints of the diagonals have to be the same. So it's got to be H. Okay, now you guys will have to do number 4. Now y'all, look, it looks tricky, but it's really not. All you gotta do is just go through and read and see what you're trying to prove after each one. So my suggestion to you would be to look at the first one for each of these and see if it makes sense with what the paragraph is trying to say. And then that will help you narrow down your choices from there. All right, number 5. Okay, number 5, number 6, very similar here. So what we're going to do for number 5, we're going to cut this up. We can create a rectangle, and then if you cut this right here, you get a triangle. Okay, so we can make a rectangle and a triangle. So the area of our rectangle is going to be 17 times 10, which is 170. Now, our triangle. This is a right angle here. So we have our base and our height. Our height will be 7. Our base, we got to figure this out. Okay. This 17 goes from end to end. The 13, it stops right here and goes straight up. So 17 take away 13, what's this little piece going to be? It's got to be 4. So the area of the triangle, it's base times height divided by 2. So 4 times 7 divided by 2. 28 divided by 2, it's 14. So this guy's area is 14. So we have the area of the rectangle plus the area of the triangle. We got to add them. 170 plus 14. It's 184, and we got inches squared. So there we go. And number 6, same concept, y'all. Exact same concept. So when you have shapes like this, y'all have to see what kind of shapes that you can break these things into. Now, is the way that I broke it up the only way to break it up? No. There's always more than one way. All right, number 7, find the area of the shaded region. Okay, it's going to be the area of the whole thing. And then you take away the area of the unshaded part. So you got to find the area of the bigger, it'll be a square, and take out the area of the smaller square. Now I know they're squares because both of the sides right here are the same. So that means all 4 sides are the same. So area of the whole thing. It's side squared. So the big square, it's 20. So 20 squared, which is 400. Now I got the area of the unshaded part. Okay, this is also square because it's 10 by 10. So it's side squared. So it's 10 squared, which is 100. And so now the shaded part only, it's going to be the whole thing minus the unshaded. So 400 minus 100, and you get 300, and it's meters squared. Okay, now for number 8. Y'all look, you got the whole shape, the whole thing is that rectangle, and then you're going to want to subtract out this blank triangle. All right, so you're taking out that blank triangle on that one. Number 9, the dimensions of a square are changed proportionally by a scale factor of 4, which represents the change in the area. Okay, y'all. So remember, your area changes with the square of the scale factor. So you take your scale factor 4 and you square it, and so you get 16. The area is going to be multiplied by 16. And just think about it. If you have a little square here, and let's say the dimensions are 1, right? So 1 by 1, the area is 1. Now let's say that our sides are changed proportionally by a scale factor 4. So we're going to take our sides and multiply it by 4. So they become 4 by 4. So what's the area of that? 4 times 4? 16. Well, look, guys, our area was 1, now becomes 16. We multiplied by 16. So that's how these things are working. Okay. 10 through 15, these are just general area formulas. So the first one we'll do is number 11. Okay, this one can be a little bit tricky. You see here, we got, this is 60 inches. It's right here, that's 60 inches. So they tell us the height of it. So we have, it's a parallelogram, so we got base times height. So we have 72 times 60. Because remember, your base and your height are always at that right angle. So you have to do 72 times 60. So it's going to be 4,320. And it would be inches squared. Okay, so 4,320 inches squared. Alrighty, now we will do number 13 here. Okay, you can see from the markings that this is an isosceles, isosceles triangle. You got two congruent legs. So if this side is 6 square root of 3, this side is also 6 square root of 3. So now, area of a triangle, base times height, divide by 2. So 6 square root of 3 times 6 square root of 3, divide by 2. So now we'll just kind of work this out. So you're going to multiply 6 times 6, that's 36. Okay, times, now you have square root of 3 times the square root of 3, which is just going to be 3. And you have that divide by 2. So 36 times 3 divide by 2. And you should get 54. So it's going to be 54 centimeters squared. Okay. So when you're multiplying these, you multiply the 6 times the 6. So you do the 6 times the 6, and that gives you the 36 here. And then you will do the square root of 3 times the square root of 3, which gives you just 3. All right, and then the last one here is number 15. Okay, number 15. This is a rhombus square here. So we're going to go on ahead and figure this out. Now, it's a rhombus. We're not sure if it's a square because we don't know about these diagonals. We don't know if they're equal or not. But you see this 15? We're going to have to use Pythagorean Theorem so we can find out this part of our rhombus. We got to figure out our other diagonal because the area is 1/2 d1 times d2. Well, right now we know d1. This half is 12 and this half is also 12. So d1 is 24 from end to end, 12 plus 12. Now we have to figure out d2, the other part here. And in order to do that, we have to use Pythagorean Theorem. So we've got this triangle, okay? This is a right triangle. And all 4 of the sides are the same. So this is 15 right here. This side is 15. So we've got our right triangle that looks like this. We have 15 on the hypotenuse. And then 12 is this one leg. And we need to find this one. So we got to do a squared plus b squared equals c squared. So 12 squared, that's what I'm going to call a, plus b squared equals 15 squared. So 144 plus b squared is equal to 225, because that's what 15 squared is. And you just take 225 and you take away 144. And so you get b squared is 81. So to find b, take the square root. So b is 9. Okay, so b is 9. And that's going to be each half of your diagonal. So this top half is 9, the bottom half is 9. So diagonal 2, it's 18. And so now we'll find the area. It's 1/2 times d1, which is 24, times 18. And so you just plug that in. And you should get 216. So it's 216 millimeters squared. And that's it. So when you got your rhombus, you're going to have to use Pythagorean Theorem to figure that out there. Alrighty. And then for number 12 and 10, 12, that's a regular pentagon. So you've got to use that A equals 1/2 apothem times perimeter. Okay. 10 is a triangle. 14 is a trapezoid. All right. Now here. Okay, 16 through 19, it's all about arcs. Let me make a note though before we go on. On number 14 here, okay, just make a note. You've got to figure out what this little part is right here, from here to here, and you're going to have the same kind of triangle over here. Okay, and this is a right triangle there, and you see how they give you the hypotenuse and they give you one leg? You're going to have to use Pythagorean Theorem on this triangle to figure out this little section, which is going to tell you this section, and then help you figure out your height up here. So this 36, well, you don't really need that extra triangle there. This 36 goes from here. No, the 36 is the whole base. Okay, so you do need this triangle. I'm sorry. The 36 is the entire base, and you got to figure out what these two little sections are. I'm marking in green so that you could figure out this part up here. Okay, because you see you're making this rectangle there. So use Pythagorean Theorem on these triangles. Figure that out first, and that'll tell you with the top. Okay, now let's go on here to arc measures. And again, I'll do the odds, you guys do the evens. So it says from circle T to the right, find the measure of the following arcs. Okay, so we need the arc AEG. So they should have the arc symbol. All right, AEG. Okay, that means you start at A, and we're going all the way around until we get to G. The E told us which way we're going. So we pass through this arc, and this arc. So we've got to combine all of those. So we have to do the 30 plus the 28 plus the 152. And so if you add these up, you should get 210. Okay, 210 degrees. Now AEN. Okay, so AEN. We start at A, we go in the direction of E, and we keep going until we get to N. So we stop right here. So we have the 30, the 28, the 152, and the 60. So basically we just add them. So 30 plus 28 plus 152 plus 60. And so when you add all that together, you get 270. All right, next page. Like I said, guys, this is going to be a lot of information. Okay. I will do number 20 with you guys just because the way that we learned it, it looked a little bit different, but y'all, it is the exact same thing. Okay. How do you find the radian measure of 60 degrees? Okay, so this is going from degrees to radians. So remember, it's degrees times pi over 180. Okay. Now look at all your answer choices here. Okay. It says divide 60 degrees by 360 and then multiply it by pi to get pi over 6. Divide 60 by 120, then multiply it by pi to get pi over 2. Divide 60 by 180, then multiply it by 2 pi to get 2 pi over 3. Or divide 60 by 360 and then multiply it by 2 pi to get pi over 3. Okay, y'all, easy way to do it. Look, you've got all these answers here, right? So let's try it. We'll do 60 times pi over 180. Now remember, in the calculator, you're going to put 60 times 1 over 180. And that's going to give you 1/3. So when you add the pi into it, you're going to get pi over 3. Or some of y'all will put 1 pi over 3. Okay, now look at the answers here. Pi over 6, pi over 2, 2 pi over 3, or pi over 3. Be careful. We have to choose pi over 3. So J is the correct answer. But look what it said. Divide 60 degrees by 360 and then multiply by 2 pi. Okay, y'all? This whole pi over 180, that is equivalent to 2 pi over 360, okay? These two things are equivalent. So these are the two ways that you'll see finding radians, or finding radians expressed. It's either pi over 180 or 2 pi over 360. But just make your life easier, calculate it the way that you know, and then match your answer that you get. All right, so now we've got arc measures and segments, all that good stuff, and inscribed angles, which we covered on Monday in class. So first one, number 21. We're going to find x degrees. So right here we have a diameter. So we know that the 67 and then this 90 and this x have to add up to 180. So basically we'll do 180 minus 90 minus 67, and that's x. So 180 minus 90 is 90, 90 minus 67, 23. So x is 23 degrees. All right, 23. This is chord. So remember, we have the parts of one line multiplied together is equal to the parts of the other line multiplied together. So you have 5 and x. So you have 5 times x. So that's this part here and this part here. And then we have the x minus 6 and then 8. So that's got to be equal. So 8 times x minus 6. And then we'll go through and we will multiply here. So 5x is just 5x. Now, distributive property. Y'all have to be very careful. Y'all were making a lot of mistakes with your distributive property the other day. So you get 5x is equal to 8x minus 48. Okay, you've got to get that there. So now we'll go on ahead. We'll take this 48 over to the other side. Or no, let me back up. Let me just do it the way you guys are going to do it. Okay, you're going to see this 5x over here. You're going to take this 8x over to the other side. So minus 8x minus 8x. Now, y'all have to be careful. 5 minus 8 is negative 3. So it's negative 3x is equal to negative 48. And so now divide by negative 3, divide by negative 3, and you'll find that x is 16, I believe. Let me double check here. Yes, 16. Okay. Now let's go here. We'll do number 25. All right. This one is secant secant. So remember, it's the whole thing times the outside is equal to the whole thing times the outside. So this one, the whole thing, 20 plus 14, that's 34. On this one, the whole thing, it's 11 plus x. So we have the whole thing here, 34, times the outside, which is 14, is going to be equal to the whole thing, 11 plus x, times the outside part, which is just 11. So I'm going to put that in front of the parentheses. So now just, we're going through, we're calculating. 34 times 14, that's 476. And then we got to do the distributive property here. So 11 times 11, that's 121, plus 11x. Okay, minus 121. So I'm going to come up here. So we have 476 minus 121. That's 355, and that's equal to 11x. So divide by 11. And we'll round to the nearest tenth. So we get x is 32.3. Okay, so 32.3. Okay, now number 27. This is an inscribed angle. So remember, your angle is half of that arc. So when you're going from the arc to the angle, you're just dividing by 2. So x is going to be 32 divided by 2, 16 degrees. Okay, now 28. It's a little bit challenging, but not too bad. I'll just help you set it up here. On this one, I would just think going from the angle out to the arc. What do you have to do to go from the angle to the arc? It's times 2. So this 4x is going to be equal to 2 times that x plus 30. And there's the setup for that. Alrighty. So now number 29. It says segment AC and segment BD intersect at the center of the circle shown below. If the measure of angle BDC is 30, what is the measure of minor arc AB? So BDC, okay, BDC, this angle. All right, always trace that V that you're making. So BDC is 30. You know, 30 here. Now we're trying to find the measure of arc AB. Okay, so let's look here. Y'all see this line AC. Now it's creating a semicircle. So I know that from A going around to C, that's going to be 180 degrees. So if I can figure out CB right here, if I can figure out CB, then I could figure out what AB has to be. And I can figure out CB by knowing that I have this angle, the 30, and it's creating that arc CB. So to go from the angle to the arc, we have to multiply by 2. So we got to do 30 times 2. So this part right here from C to B is 60. And I know that from C all the way around to A, it's got to be 180. So the measure of arc AB is 180 minus 60, which is 120. All right, and then 30 is very similar. Y'all use colors and trace out your angles. If you will trace that, it will help you to find what you need to find. Okay, last page. Here we go. I know this has been a little bit of a long video, but there's a lot of information on this test, like I said. Okay, find the area of each shaded sector of a circle. Leave your answer in terms of pi. Okay, so area of a sector. It's the arc out of 360 times pi r squared. That's your formula for area of a sector. Now we're finding the shaded portion. Okay, number 31. We need to figure out how many degrees that whole shaded portion is. The entire circle is 360. Take away the unshaded part, which is 60. It's 300. So you have 300 degrees. So we got 300 out of 360 times pi. Now we need r squared. Okay, our radius is 6, so 6 squared. Now to leave your answer in terms of pi, type everything into your calculator except for pi. So do 300 divided by 360 and multiply that by 6 squared. And when you do that, you'll get 30, but we have to put the pi on. So it really comes out to be 30 pi, and then it's feet squared. So the answer is 30 pi, not just 30, 30 pi. All right, 33. This one here, we only want this shaded section. And I've got the semicircle, and we already know this part over here is 120. So I could do 180 minus 120 gives me 60. So this arc measures 60 degrees. So we have 60 out of 360 times pi. Now we need r squared. The 12 is the diameter. We only want half. So half of 12 is 6. So times 6 squared. And again, put 60 divided by 360 and then multiply that by 6 squared. And so you get 6, and then put your pi on the end. So it's 6 pi, and then whatever units squared. Next one, arc length. It says find the length of each darkened arc. Leave your answer in terms of pi. All right, 35. Our arc is 180 degrees. And remember, our formula is the arc out of 360 times 2 pi r, because we're multiplying it by the circumference. So we have 180, that's our arc, out of 360 times 2 times pi. Now our radius. 22 is your diameter. You have to cut it in half. So half of it is 11. So times 2 times pi times 11. And again, to leave our answer in terms of pi, multiply everything except for the pi. So 180 out of 360 times 2 times 11. You'll get 11. And you'll put the pi on the end, and it's meters. So 11 pi meters. Last couple. Okay, number 37. Find the measure of one interior angle of the regular polygon. Round to the nearest tenth. So I'm going to go ahead and give you these formulas again for 36 and 37 so we can remember. For 36, they want the interior angle sum. So the sum of your angles is n minus 2 times 180. So that would be all the interior angles added together. For 37, we want the measure of 1. So we still have to find all of them, n minus 2 times 180, but then we have to divide it by n, the actual number of angles that we have. And that will give us just 1. So in this one, we have a pentagon, so it's 5 sides, so 5 minus 2 times 180, and then we divide by 5. Okay, and so when you do that, put that straight into your calculator, you'll get 108 degrees. So each one of those angles is 108 degrees. Okay, now 38 and 39, they use the same formula. It says find the measure of one exterior angle. Now if you remember, the exterior angles are these ones on the outside. All of them add up to 360. So if I want to just find one, I have to take 360 and divide it by the number of actual exterior angles that there are. So the formula is 360 divided by n. So number 39, number your sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 sides. So we have to do 360 and divide it by 11, and you will get 32.7 degrees. Okay, so we've gone through, we've done all of the odds, a couple of the evens. I'm going to go through here in a second. I'm going to put, at the end of this video, I'm going to go back and write down the answers for each of the evens so that you can, work and see if you get that correct answer. So there's not going to be work for them, but you'll have the answer so that you can see if you've done it correctly or not. So I'm going to pause really quick and do that, and then I'll come say goodbye. Okay, guys, so I've gone through and I've put the answers for all of the evens as well, just so you can see there. And so now it's your guys' job to go through, do the evens, make sure you've gotten those questions correct. If you haven't understood how to do an odd, please go back and re-watch the problem. Okay, sometimes I have to explain things very quickly, but go back and re-watch it. That's the beauty of a video. You can watch it as many times as you need. So please go back, re-watch anything you didn't understand, look over your notes. Like I said, this test covers a lot of material. So you're really going to have to buckle down and study. So good luck. We've done half of them together. You got the answers for the other half. You don't have that much work to do. And I'll see you guys later. Bye.